Humankind has always been driven by a thirst for understanding. We yearn to unravel the mysteries of the cosmos and our place within it. One of the most profound questions that has echoed through the ages is deceptively simple. What is the universe made of, and what holds it together? This pursuit of a unified understanding of nature's workings lies at the heart of the search for a theory of everything. Imagine a single, elegant framework that could explain the behavior of all matter and energy, from the smallest subatomic particles to the grandest galaxies. This is the ambition of the theory of everything, a theory that would weave together all aspects of the physical world into a seamless tapestry. For centuries, physicists have chipped away at this grand challenge, piecing together fragments of knowledge like pieces of a cosmic jigsaw puzzle. The journey towards a theory of everything has been marked by both stunning triumphs and perplexing roadblocks. We've made incredible strides in uncovering the fundamental laws governing the universe. Yet some pieces of the puzzle seem to stubbornly resist fitting into the grand scheme. The search for a theory of everything is a testament to the audacity of human curiosity, a relentless pursuit of nature's deepest secrets. Our current understanding of the universe recognizes four fundamental forces that govern the interactions of matter and energy. Like unseen puppeteers, these forces orchestrate the cosmic dance of particles, dictating how they attract, repel, and transform. They are gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Gravity, the weakest of the four, is the familiar force that draws us to the Earth and holds planets in orbit around stars. Electromagnetism, responsible for light, electricity, and magnetism, governs the behavior of charged particles. The strong nuclear force, as its name suggests, is incredibly powerful and binds protons and neutrons together within the atom's nucleus. Lastly, the weak nuclear force is responsible for radioactive decay, a process crucial for the existence of elements heavier than hydrogen. The theory of everything seeks to unify these seemingly disparate forces, showing that they are merely different facets of a single fundamental interaction. Imagine these forces as four streams flowing down a mountainside, seemingly separate and distinct. As we trace them back to their source, we find they converge into a single, powerful torrent. This is the essence of unification, revealing the underlying unity beneath the apparent diversity of nature. In the 20th century, physicists developed the Standard Model of particle physics. This remarkably successful theory describes the electromagnetic, strong, and weak forces and classifies all known elementary particles. The Standard Model has been rigorously tested and has made astoundingly accurate predictions, solidifying its place as one of the most successful scientific theories ever devised. However, the Standard Model has a glaring omission. It fails to incorporate gravity. While it elegantly describes the subatomic world, it stumbles when confronted with the force that shapes the universe on the largest scales. Einstein's theory of general relativity, which describes gravity as the curvature of space-time caused by mass and energy, remains incompatible with the quantum framework of the Standard Model. This incompatibility between the Standard Model and general relativity is a major stumbling block in the quest for a theory of everything. It suggests that our current understanding is incomplete, hinting at a deeper, more fundamental theory waiting to be discovered. Like a map that accurately depicts continents but leaves a gaping hole where an ocean should be, the Standard Model, for all its successes, remains incomplete. Enter string theory, a revolutionary approach that attempts to bridge the gap between quantum mechanics and general relativity. String theory posits that the universe is not made up of point-like particles but rather of tiny, vibrating strings. Imagine these strings as the fundamental chords of a cosmic symphony, their different vibrations giving rise to all the particles and forces we observe. Just as a violin string can produce a variety of notes depending on how it vibrates, different vibrations of these fundamental strings correspond to different particles and forces. Gravity, electromagnetism, the strong and weak forces, they all emerge from the harmonious interplay of these vibrating strings. String theory offers a tantalizing glimpse into a universe far stranger and more beautiful than we could have imagined. It paints a picture of a reality where dimensions beyond our perception curl up at the smallest scales, and where the fabric of space-time itself is woven from the vibrations of these fundamental strings. Section 5. Loop Quantum Gravity Space-Time as a Woven Fabric. Loop quantum gravity, or LQG, offers a different perspective on unifying quantum mechanics and gravity. Instead of starting with particles and trying to incorporate gravity, LQG begins with Einstein's theory of gravity and attempts to quantize spacetime itself. Imagine the fabric of spacetime as a smooth silk sheet in classical physics. LQG, however, proposes that if we could zoom in close enough, we would see that spacetime is not smooth at all but rather woven from tiny, interconnected loops. These loops, much like the threads of a tapestry, give spacetime its structure and define the smallest possible units of area and volume. In LQG, gravity arises from the quantum properties of these spacetime loops. It elegantly addresses some of the problems that plague other approaches to quantum gravity, such as the singularity at the heart of black holes. However, LQG is not without its challenges, and much work remains to be done to fully develop its framework and explore its implications. Section 6, M-Theory and Beyond, a tapestry of universes. As physicists delved deeper into string theory, they discovered that it wasn't just one theory, but a family of related theories. This realization led to the development of M-Theory, a framework that attempts to unify all 5 consistent versions of string theory. M-Theory proposes that our universe is just one of many membranes, or branes, floating in a higher dimensional space. Imagine these branes as slices of bread in a cosmic loaf, each slice representing a different universe with its own unique set of physical laws. Collisions between these branes, according to M-Theory, could potentially explain the Big Bang and the origin of our universe. M-Theory is a mind-boggling concept, pushing the boundaries of our imagination and challenging our understanding of the very nature of reality. It hints at a vast multiverse, a tapestry of universes woven together by the intricate interplay of strings and branes. Another compelling contender is E8 theory. This theory attempts to unify all known forces and particles as different aspects of a single, elegant mathematical structure known as the E8 Lie group. E8 theory holds the promise of a deeply unified and mathematically beautiful description of the universe. Section 7. Visualizing unification, a symphony of strings. The unification of particles and forces within these theories can be visualized through the analogy of a musical instrument. Imagine a single string, representing the fundamental entity in these theories. Its different vibration modes, like the different notes played on a guitar string, give rise to the diverse array of particles we observe. The image above illustrates this concept within the framework of string theory. The different vibration patterns of the strings, represented by the loops, correspond to different particles and forces in the standard model. For instance, a string vibrating in one particular mode might correspond to an electron, while another vibration pattern might represent the photon, the particle of light. This visual representation highlights the elegance and unifying power of these theories. They suggest that the seemingly disparate particles and forces we observe are not fundamental but rather arise from the different facets of a single underlying entity. Section 8. The Unfinished Symphony, Challenges and Hopes. Despite the promise and elegance of these unifying theories, none have yet achieved the status of a complete and experimentally verified theory of everything. String theory, for instance, requires extraspatial dimensions beyond the 3 we experience, and their existence remains purely theoretical. LQG, while successful in some aspects, still faces challenges in describing all forces and particles. These challenges highlight the fact that the search for a TOE is still a work in progress. Further theoretical development and, crucially, experimental verification are needed to determine which, if any, of these theories accurately describes the universe at its most fundamental level. The quest for a TOE is a testament to the power of human curiosity and our relentless drive to understand the universe. It is a journey driven by the belief that beneath the complexity and diversity of the cosmos lies an underlying simplicity, an elegant set of principles that govern all of existence. Section 9. The Potential of Unification. The discovery of a TOE would be a watershed moment in the history of science. It would not only provide us with a deep and satisfying understanding of the universe, but could also have profound implications for our technological advancement. Harnessing the power of quantum gravity, for instance, could revolutionize space travel and energy production. Moreover, a TOE could shed light on some of the most profound questions about the universe, such as the origin of the Big Bang, the nature of dark matter and dark energy, and the ultimate fate of the cosmos. It could potentially provide answers to questions we haven't even thought to ask. The search for a TOE is more than just a quest for a single equation. It is a journey into the heart of reality, a pursuit of knowledge that has the potential to transform our understanding of the universe and our place within it. It is a journey that may ultimately lead us to a deeper appreciation of the beauty, elegance, and profound unity of the cosmos.